So we are going to be filling out one more section of this foldable graphic organizer. Some of you may have glued it to the first page of your tools packet for the quarter. Others of you, it might be in your folder. There are a few extras, so ask Ms. Husak if you were not here or if you can't find it. Get that out, pause the video, make sure you're ready to roll, and then go ahead and open it, and we'll take notes on finding slope from a graph. Okay, so I am down on number 5, our first example of how to find slope on a graph. The first thing we're going to talk through is how this is connected to what you have already done. So there is a way to find slope from a graph that looks exactly like what you have been doing. And that way would be if we can start at the origin and we can identify the coordinate of this point, and then we can go back to the origin and identify the coordinate of this point, we could put those two things into a table and calculate the slope just like we did with numbers 3 and 4. So we're going to do that first. I am going to make my parentheses and my comma and get ready for my coordinates. I'm going to go to the origin. My goal is to get to this point right here. I'm going to count over 1, 2, 3, 4. So that means that my x coordinate is 4. And then I am going to, from there, count up 1, 2, meaning my y coordinate is 2. So the point at the top of this line is 4, 2. Now I'm going to go back, and I'm going to go back to the origin, and I'm going to count over to the other point that's on the line, the one that's down below the x-axis. 1, 2, 3. I have to get my parentheses ready like I did last time. The x-coordinate is 3, because I go over 3. And my y-coordinate looks like pretty easy. It's down -1. I just go down 1 from the x-axis. So now that I've got those 2 points, I'm going to come over to the left-hand side of my graph, and I'm going to build my mini table. Got my x's on the left, my y's on the right. So that means I've got 4, 2 for my first point, and 3, 1 for my second point. And if I calculate how I go from 4 to 3, that is -1. If I calculate how I go from 2 to 1, oh my goodness, 2 to -1. I just caught my mistake. That is actually down 3. Sorry about that mistake. Now I'm going to start talking about my little formula we have here. Our formula says that our slope is made up of our change in y over our change in x. That means that my slope is -3 over -1. Now yesterday we ran into this where we had 2 negatives, and I know that's a positive, and I know that 3 divided by 1 is 3. So my final answer after I take -3 divided by -1 is 3. My slope is 3. So I'm going to go over to my answer rectangle over here and say m equals +3. Now there's another way to find slope from a graph that doesn't involve identifying the coordinates. We're going to practice that next. As we move over to 6, we're going to take a look at the points differently. And instead of counting with math on the number line, our up and down movements, we are going to do it right on the graph. So I'm going to take a look at my first point here, And my goal is that I want to figure out from this point to this point, what is my change in y, or how far up or down do I need to go to get from this point to this point. We can do it with math, like we did over here, figuring out how far we're moving, or we can just look at the graph. So what I'm going to do is start with the point on the left, and I'm just going to figure out that if I start there, my y, or my up and down coordinate, goes down 1, 2, 3, 4 spaces to go from one point to the other. The distance that I travel up and down between these 2 points is 4. So that would mean that my change in y equals -4. I'm going down 4. Now I've got to do the same thing, but I've got to do it with my x value, knowing that x is side to side. If I'm starting at this point, I've gone down 4. How many squares, or how many jumps over do I go? So if I'm starting at this point, I've already gone down. I need to move over 1, 2, 3, 4, 5, 6 leaps to the right. I'm going to make that a little bolder. I need to go 6 leaps to the right, which means that my change in x is 6. And I know that it's a positive 6 because I'm moving in the positive direction on my number line. I'm moving from left to right, which is going positive. If it helps you, what you can do is label each of your positive and negative directions on your different axes. From one point to the other, if you're moving to the right, you're moving in the positive direction, or if you're moving up, you're moving in the positive direction. On the other hand, if you're moving to the left or down, you're moving in the negative direction. So now I go to that same formula that I've had, which says that m is equal to my change in y over my change in x, and I put my -4 in the numerator position and my +6 in the denominator position. I have to reduce. I know that these are both even numbers, so I can divide -4 by 2, and I can divide -6 by 2. And if I jump, I'm actually going to jump to the other side of my graph to finish this. What that leaves me with is a -2 over 3. So my slope for this graph is m equals -2/3. Now I know to leave this as a fraction because it is in fraction form. It's got a smaller number on the top, a larger number on the bottom, and I cannot reduce it anymore. On the other hand, when I was over here, I had a larger number on the top and a smaller number on the bottom, so I had to test out if I could divide and get a whole number, and I could. Each slope is a little bit different, and if you use your answer key as a guide, I think you'll start to see the pattern of when you reduce, when you divide to get a whole number, and what happens if you have an improper fraction. Good luck, move on to your homework, and check in often with the people around you to see if you're on the right track.